Hi dear students, welcome you all to the Brilliant Group of Institution. Today we are continuing the chapter Biomolecules, most important MCQ. Okay, so directly we can enter into the question. Here we have the question. In DNA, the complementary bases are, DNA, it's having a double helical structure, right? DNA having a double helical structure. This is one of the strand, the other strand. And the one strand is 5' 3' carbon. It is complementary strand, therefore 3' and 5'. Alright. So the question, in DNA the complementary bases are, if in one strand we have adenine, definitely what should be the other strand? Thymine. Alright. Adenine and thymine, bonded through a double bond. This is one of the base pair. Whereas the guanine, suppose if it is there in one strand, definitely it has to make a bond with cytosine through a triple bond, right? So what are the bases? What are the bases which is present? Base pair in a DNA, that is always adenine with a thymine through a double bond, guanine with a cytosine through a triple bond. Alright, so in DNA the complementary bases are adenine and thymine, guanine and cytosine, right? Option B is the correct answer. Clear all of you? Next question. A nucleoside on hydrolysis gives. Last the part 1 video we discussed what is nucleoside, what is nucleotide, everything. Alright. So nucleoside on hydrolysis. Nucleoside is made up of, we studied that it having a pentose sugar. Alright, it's having a pentose sugar. The first carbon which is connected to the nitrogen contained base. So a pentose sugar with a base is called what? Nucleoside. So nucleoside on hydrolysis, what all components you will get it here all of you? A aldopentose and phosphoric acid, no, a aldopentose and a nitrogenous base. Alright, option A. Nucleoside which contain pentose sugar and base. What is a nucleotide? This is first carbon, second, third, fourth, fifth. The fifth carbon which is connected to phosphate group, then all together is called which one? Nucleotide. Alright, nucleotide. So here the question, nucleoside, what all contains? When it is dissolved in water or when it is hydrolyzed, yeah, it will give you what are the small components or what all things are there in nucleoside. So your answer is aldopentose and nitrogenous base. Alright. Next one. Nucleic acids are. What are the nucleic acids we have? DNA and RNA. DNA and RNA. Deoxyribonucleic acid. RNA, what's that? Ribonucleic acid. They are small molecule. No, dear student, they are large giant molecule. They are polymers, right? And dipeptide, no, right? And long chain polymers of nucleotide. Yes, we know nucleoside, right? Nucleoside, pentose sugar with a base. On the nucleoside, the fifth position connected to the phosphate group, like the previous case, that is called what? Nucleotide. Nucleotide. Many number of nucleotides are combined together. It will undergo polymerization. It will give you nucleic acid, right? Nucleic acids. All right, nucleic acids. So nucleic acids are the long chain polymers of nucleotide. Option C is the correct answer. Dear? All right. Next one. On boiling egg, in the chapter biomolecule, we studied that the process called denaturation of protein, right? What is mean by denaturation? A protein with a perfect biological structure and biological activity, that is called native protein. When this native protein subjected to any physical change, like change in temperature or like any changes in chemical change, like change in pH, the native protein completely changes to denatured protein. During this transformation, like this native protein converted to the denatured protein, so many changes are happening. What are the changes? We know secondary and tertiary structure of protein completely destroyed. And primary structure, nothing happened, it remained the same, it remained intact. And what about the biological activity? The native protein having a particular biological activity, but when it is undergo denaturation, the biological activity losses. Similarly, you may study globular protein, right? Globular protein when you heat it, what happened? That unfold and it become fibrous like one. So many changes are happening during a denaturation. So on boiling of egg, the curdling of milk, all are example for which one? Denaturation of protein. On boiling of egg, what structural changes are taking place in the egg white? Option A, color of the egg. You know, need, right? Because the question is structural change. What is that? Secondary and tertiary structure are destroyed, but primary structure remain intact. Of course, that's a correct answer. Alright, so during denaturation, what all things are happening that we have to know very well. Secondary and tertiary structure completely disturbing, primary structure remain the same intact, and biological activity loses, the globular protein get unfold, converted to fibrous protein. Alright, next question all of you. Mark the wrong statement about denaturation of protein. Alright, denaturation of protein, what are the wrong statement? Option A, primary structure of the protein does not change. Correct statement, right? Globular proteins are converted to fibrous protein, right? You know, globular proteins, when it is heated, it becomes what? Fibrous protein, right? It's become fibrous protein. Correct one. Fibrous proteins are converted to globular protein. No, that is a wrong statement, dear all of you. Option C is the wrong statement. And biological activity of the protein destroyed, right? Of course. So option C is the correct answer. Next one. Which type of interactions are responsible for making the alpha helix structure stable? You may study the secondary structure, right? The secondary structure of protein are of two types. One is called alpha helix. The second one is called beta pleated structure, right? Beta pleated structure. Okay. Alpha helix and beta pleated. All right. In the alpha helical structure, you may study the helical geometry, right? The helical geometry is like this. And question, which type of interactions are responsible for making the alpha helical structure? Okay, helical structure. Okay, helical structure. What is the responsibility? You know, if you consider this is a polypeptide chain, a protein chain. Protein, you know, it contain acid group and amide, the like amine group. Overall, amide linkages will be there, right? So in one strand, what happened? CO group from the acid group, CO group will be there. Maybe from another turn, we may have nitrogen with a hydrogen. All right, nitrogen with a hydrogen. Amine group is there. You know, this oxygen and hydrogen which can connected through which type of bond? Hydrogen bonding, right? Hydrogen bonding. What is hydrogen bond? Hydrogen connected to highly electronegative elements like oxygen, nitrogen, fluorine, etc. So here oxygen and hydrogen can make a hydrogen bonding. All right. So, why this turn? Why this helical structure? How it is generating? Because this one, what we said. In one turn, CO group from amino acid. From the other turn, NH group are joined together through hydrogen bonding. So if it is a helical, if it is a linear polypeptide chain, when you consider one strand CO group from the other strand, if there is a NH group projected, this CO and NH will combine together. So force is stronger. So when the force stronger, they become helical in geometry. So alpha helix structure is stable due to which type of interaction? Option A, peptide bond between NH2 and CO group of adjacent carbon chain, not peptide chain. Peptide bond is there in the long protein chain. It's all protein chain containing peptide bond, but not making stabilized. Hydrogen bonds between, hydrogen bond between NH of amino acid in one turn with CO amino acid to adjacent. Yeah, that's making a alpha helix structure more stable. All right, dear all. Next question for you. Most common type of secondary structure of proteins are. Which is the most common type of secondary structure? Just we said now, alpha helix and beta pleated. Alpha helix and beta helix. No, alpha helix and beta pleated sheet-like structure. Option B is the correct answer. Next question. Primary structure of a protein is. We studied protein having total 4 structures. Fourth quaternary structure is very rare, you know. Primary structure, what is meant by primary structure? Various amino acids. The amino acids are arranging on a polypeptide chain with a specific and sequential arrangement. the specific and sequential arrangement of amino acids on a protein chain is called what? Which is called primary structure of protein. So primary structure of protein is option A, sequence in which alpha amino acids are linked to one another. Is it? Sequence in which alpha amino acids are linked to one another. Yeah, this is called primary structure. Is it option B? Sequence in which amino acids of one polypeptide chain are joined to another chain. No, within a polypeptide chain, how does amino acids are specific and sequentially arranged? That is called primary structure of protein. So dear all of you, your answer is option A. Next. The peptide linkage, peptide linkage is the linkage between two amino acids, right? The peptide linkage formed between glycine and alanine. The first amino acid, glycine and alanine. Already they given the structure. Okay. So let me write the structure of glycine first of all, NH2. Okay. So let me take the NH2 group, CH2 group, and we have COOH group. All right. Plus this is glycine. Let me mix with alanine. Let me write NH2, CH3, and we have COOH. Okay, let's react. What happened here all? Here very simple reaction. Amino acids are joined together by the elimination of water. So wherever you can observe carboxylic acid. So this is the interaction part, right? So from carboxylic acid, you can take the OH group. From NH2 amine group, you can take one hydrogen, you can eliminate water. All right. What is left in the system? You have NH2, CH2, C double bond O. Yes, what do you have here? NH, right? NH. And we have CH, CH3 and COOH. Correct. This is the amino acid. This is called what? Glycine and ala. This is the polypeptide chain. So this is the peptide chain bond form here, CONH. Right, peptide linkage is a amide linkage. CONH linkage is called what? Amide linkage, or it is called peptide linkage. So where you can observe this figure, all of you, just check it. NH2, CH2, CONH, CH, CH3, COOH. Option B, right? All right, NH2, CH2, CONH, CH, CH3, COH. Right, option B is the correct answer. Right, just clap it by the elimination of water. Next question. Which of the following represent a peptide chain? As I told you, peptide chain contain which interaction? CONH linkage. This is called peptide linkage or amide linkage. This is the connecting part. Can you see here? NHCONH. One more NH is there. NHCONH. Here NHCONH. Possible? Right, dear students? CONH only. The other part will be mostly carbon containing compounds. So this is not possible. Option B, NHCO carbon. Yeah, correct one. NHCO carbon. Alright. But here you see, dear all of you, CH2CO. Right? NH bond is not there. Not B. Here you can observe NHCH2CONH. Yes, can you see CONH bond is there? Here and here are carbon we have amide linkage. Here carbon CONH, right? CONH bond is there. Here also carbon. Yeah, this is a perfect amide linkage. What about here? CONH is there, okay, fine. But here COCH2, no. What group should be there? CONH should be there, and nearest the connected elements are carbon. This is called a peptide linkage in a amino acids are joined together in a protein. Alright, so option C can be the correct answer. Next, which of the following statement is not correct? Option A, proteins are polyamides formed from amino acids. Yes, amino acids are joined together one by one, which making a amide linkage, right? Polyamide, many amide linkages will be there. Correct statement. Except glycine, all other amino acids show optical activity. Yes or no? Yeah. What is glycine, dear all of you? General formula of amino acid is this one. Right, this is called the general formula of amino acid. If the R group is hydrogen, we will call it as, this is the first amino acid, glycine. Dear all of you, what is the condition to make a compound as optically active? if a substance want to be optically active, at least one chiral carbon is necessary. Is it contain any chiral carbon? No, dear all of you. This carbon you see, it is connected to two same element, hydrogen. What is a chiral carbon? All the surrounded elements or groups on the carbon atom should be different. So this carbon is what? A chiral. A chiral. What about this carbon? This is C double bond O, right? C double bond O. Two valencies are connected to the same element, oxygen. This is also a chiral. So glycine doesn't contain any chiral carbon atom. Therefore, glycine is optically inactive. Optically inactive. What about other naturally occurring amino acids? All of them contain at least one chiral carbon. All are optically active. So this is a correct statement, okay? Except glycine, all other amino acids show optical activity. Yeah. Natural proteins are commonly made up of L isomers of amino acid. Last class also we discussed. Naturally occurring amino acids having L configuration. L configuration, correct statement. So option D only the possible answer. Because question is which is not correct. In alpha amino acid, NH2 and COOH groups are attached to different carbon atom. No, dear all of you. See this is the general representation of an amino acid, right? Here COOH group and amino group are connected to the same carbon atom, not different one. So option D is the wrong statement. That's our correct answer. Okay, next question. A compound which contain both dash and dash is called amino acid. Amino acid mean they contain amine group and carboxylic acid group. Yes or no? Yeah. The amino acids in polypeptide chains are joined by peptide bond, right? Peptide bond. What is the answer? Amino group is there. Carboxylic group is there. Peptide linkage is there. That is option B, right? Yeah. Amino acid is there. Carboxylic acid is there. Peptide linkage is there. Alright. Where you can see the ester linkage. We studied now two nucleotides are connected through phosphodiester linkage. There is the ester linkage. Ester linkage is in between two nucleic acids. Means nucleotide. And where you can see glycosidic one. Glycosidic, you may study two monosaccharides are connected. If it is a glucose and glucose and fructose, two monosaccharides are connected through glycosidic linkage. Okay, then again peptide. Alright, next question. With what are the hydrolysis product of sucrose? Dear student, we may studied a laboratory preparation of glucose, right? From sucrose. Sucrose is C12H22O11. It is a disaccharide. When you dissolve sucrose in water, in presence of an acid, it will give you glucose and fructose. Sucrose is a disaccharide, so it should give two monosaccharide. What are the two monosaccharide? One glucose, one fructose, right? One glucose and one fructose. One glucose and one fructose. Option D can be the correct answer. Glucose and fructose. Next, pick up the incorrect statement from the following. Option A. Glucose exists in two different crystalline form, alpha D glucose and beta D glucose. Yes, right? Last class we discussed the first carbon and fifth carbon on the glucose interacting together. It's converted to alpha D glucose and beta D glucose. They are called anomers, right? Yeah, it's a correct statement. Cyclic structure of alpha D glucose and beta D glucose is called pyrano structure. Yes, glucose when we make into the cyclic structure have ortho representation. We are using pyran ring. In case of fructose, we are using furanose ring. Right, furan. Correct one. Alpha D glucose and beta D glucose are called enantiomers. No. Alpha D glucose and beta D glucose are called anomers, right? Anomers. What are anomers? They having same molecular formula. They are isomer. Their configurations are differ only in the configuration of one carbon. That is called anomers. Cellulose is a straight chain of polysaccharide made up of beta glucose. That's a correct statement. So option C is the correct answer. Next one. The letter D in carbohydrate signify. Please don't think D corresponds to dextro. Alright? D not corresponds to dextro or L not corresponds to levo. Alright? You may study that glyceraldehyde, the simplest representation of Fischer representation, that is called glyceraldehyde, right? Glyceraldehyde. In glyceraldehyde, so let me take two glyceraldehyde molecule. In glyceraldehyde, You know, the bottom carbon is CH2OH and the upper one is aldehyde. Here also CH2OH and here it is aldehyde. On the central carbon atom, if OH group right side and hydrogen left side, then it is called it as D configuration. Therefore, it is called D-glyceraldehyde. D configuration. Then on the same central carbon atom, if OH group left side, hydrogen right side, here OH right side, here OH left side. If it is left side, then it is called L-glyceraldehyde. Alright. So D and L nothing but, please don't relate to any dextro or levo. D and L represent just arrangement of the configuration. Then how you can confirm whether it is dextro or levo? Dear all of you, for dextro rotatory they will make a symbol positive. For a levo rotation they will give you a negative symbol. Did you see in your textbook? They are giving you alpha D plus glucose like that. What is the meaning? So plus, right, glucopyranose like that. But the D represent the configuration, plus represent dextro. Alright. So this, if you can see this area in a carbohydrate, you can say that it is D configuration. If you can observe this configuration in a system, then it is called L configuration. Alright. So letter D in carboxylic carbohydrate signify which one? Not dextrorotatory, diamagnetic mode of synthesis. That is nothing but configuration, D and L configuration. Alright, next one. Nucleotides are joined together by, dear student, two nucleotides are joined together through which type of interaction? Phosphodiester linkage. Phosphodiester linkage. You know, two nucleotides, the fifth carbon and third carbon are interacting. That is an ester linkage. That is called phosphodiester linkage. Alright. Phosphodiester linkage. You know, peptide linkage, it is in amino acid, right? Glycosidic linkage, it is in between. It is in between which one? Two monosaccharides. What about disulfide? Disulfide linkage you can see in fibrous protein. Next one. Glucose is a aldopentose, ketopentose, aldohexose, ketohexose. Dear student, you know the open chain structure of glucose. Here we have CH2OH and OHH, repeat OHH, opposite HOH, repeat OHH, and here CHO. This is the open chain structure of which one? Glucose. No, glucose which contain aldehyde as the major group, right? So if a carbohydrate contain aldehyde, we will call it as aldo. If it is a ketone, keto. Total how many carbons are in glucose? You know, 1, 2, 3, 4, 5, 6. So hexose, right? So this is a glucose is a aldohexose, right? Option C, glucose is an aldohexose. Next one. The monomeric unit of starch is, you know, starch, cellulose, glycogen, all things we studied under polysaccharide, right? Starch which contain fully alpha glucose, alpha D glucose. Glucose is the only monosaccharide present in starch. So your answer is which one? Monomeric unit of starch is only glucose, only glucose. Then building unit of proteins are, you know, proteins are made up of amino acid. Which amino acid? Alpha, beta, gamma. Which one? Dear student, general expression we study, no? RCH NH2COOH. This is the general expression of which one? The amino acids. And here, R group can be any group, hydrogen, methyl, ethyl, anything. So depends on that, we will get various amino acids, right? Here you see which is the amine group, acid group. As per the priority order of functional group, which is the most priority group? Carboxylic acid, correct? So carboxylic acid, major group connected carbon is called alpha carbon. Alpha carbon contain amine. So what is this? Alpha amino acids. So option alpha amino acid, that is option B can be the, that is not, sorry, that is delta given, right? Sorry for that. What is that? Alpha amino acid, right? Alpha amino acid is the correct answer, not delta or beta or gamma. Alpha amino acid. Next one. Let's go to the last question here, all of you. 3 cyclic structures are given here of monosaccharide are given. Which of these are anomers? Last class also we discussed one of the same type of question. So the three cyclic structures of monosaccharide which are anomers. What are anomers once again? Anomers are isomers. So they're having same molecular formula. Only one carbon atom, the configurations are different. Maybe OH right side, H left side, H left side, H right side, OH right side, like that, opposite. See, where is the carbon atom? This is, all these are carbon atoms. So 1, 2, 3, 4, 5, 6. Total 6 carbons are there. All right. What about here? 1, 2, 3, 4, 5, 6. Okay. Here 1, 2, 3, 4, 5, 6, 7. Definitely we can cancel option 3 or the compound number 3. Why? Because the molecular formula is not matching. Then 1 and 2. We have to confirm whether 1 and 2 because all are given here like this. Okay, then fine. You can see dear all of you in the first one, first carbon atom OH right side, H left side. What about here? Opposite. OH left side, hydrogen right side. Okay. And all other carbons remain the same? Yes. OH right, OH right, H right, H right, OH right, OH right. Yeah. So here only the one carbon atom configurations are different and they're having same molecular formula. So you can confirm that they are anomers 1 and 2. In which carbon the configurations are different? What they call it as, dear all of you? Anomeric carbon. So which is the anomeric carbon here? This is the anomeric carbon. Alright, on the carbon where the configurations are different, that is called anomeric carbon. Clear all of you? Okay, so these are the questions, major question from the chapter Biomolecules. So hope you clear the concept carefully. All of you read the NCERT textbook line by line. You can able to answer or you can compete any kind of examination from the chapter Biomolecules. So we will meet again with some more new chapters. So thank you all. Goodbye.